Okay, geometry. We're going to finally finish this section 2-6. We spent some time graphing on some dot paper and doing some things for these three-dimensional figures. But now we're going to talk more about orthographic drawings, which are these guys, and then talk about like what's called a net. Not like a net that you scoop fish out of the sea with, okay? It's a net as in like if you take a box and you unfold it and lay it flat, what does it look like? And so we're unfolding and refolding together three-dimensional shapes, okay? So let's go to, I'm on example 2, and let's go down here. We already drew on the dot paper. I kind of talked a little bit about example 2, but let's go to this check right here. Which is, I don't know, halfway down the page on page 119. And we're going to talk about an orthographic drawing for this shape right here, okay? Okay, so what we want to do in an orthographic drawing is we're looking at 4 different sides to this shape, okay? Now, each shape has basically 6 different sides. It has a front, a back, a left, a right, a top, and a bottom, right? But we only do 4 because we do we do the top view, the, let's go front view, let's do the right view, and we'll do the left view, and you can put this off to the side right where I'm putting it right now. Okay, so add this to your margin over here, and we're going to talk top view, okay? Now, when we talk top view, imagine that I'm looking down on this object, but when I'm doing it, I'm like kind of facing this direction because this is the front. So this is the bottom, and this is the top of where my image is, right? Bottom, and then top. Okay, don't write that part in there because I'm going to erase it here in a second, okay? And then this is the one side, this is the other side, okay? So when I'm looking at the top down, the thing that I notice is that there's 2 blocks here and 1 block here. So I've got kind of like this L-shaped thing going on, right? And I've got 2 here and 1 here. But the thing that I notice is that these 2 here are on the same level, and this one is down lower. So I'm going to take, and if you have a different color, do a different color, or you can just make them really dark. I'm going to do that, and that will show that like this is either higher or lower. We don't necessarily know which one is which, but this guy is either going to be higher or lower than these 2, and these 2 are on the same level, okay? All right, now I'm going to erase all my stuff, and let's do the front view. So imagine that this is built, and I'm looking flat this direction, right? Like I'm looking at it flat. What I notice is that I have 3 tall here and really 3 tall there. So I have like a block of, I don't know, like 6 blocks going on here. I have this thing happening, okay? Now, if I'm looking straight in this way, this tower, these 2 blocks are going to be sticking out, which means I need to have like something like this going on, right? There's not going to be one here because these 2 are on the same level, right? But this block is like sticking out, okay? All right. Next, let's go to the right view. Oh, no, let's go to the left view. Let's go left. Okay, left view would be me looking in this direction, okay? And that's going to be completely flat on that side. Like there's no dimension change on that side. So if I do left view, I see, let me go 3 tall on this side. Like that and like that. Oh, my drawings are terrible. So 3 and then 2, and they're completely flat. There's no, I don't need to make anything pink because they're all going to be the same. Like it's just completely flat on that side. But then now if I look from the right side, which is the opposite, okay, the right side is going to be the opposite of the left side. Okay, exactly opposite. But the right side does have some dimension change, right? Like these 3 blocks are sticking out further than these 2 blocks, right? These are like back set a little bit. So I'm going to draw a pink line here and here to note that these 2 are set back. Now, looking at the right side, I don't know necessarily if those 2 are set back or if those 2 are set forward, and these are set back, but and I think Trevin asked this the other day, like, how do I know then, like, which one is which? Like, if those pink lines don't tell me for sure if it's set forward or back, that's when you have to look at all 4 of them in conjunction with each other, and you can see which one is which, right? I know that by the top view, if I'm looking in from the right view, this has to be set back further and these ones are sticking out forward, right? So looking at two views kind of at the same time while you're building this thing can tell you what he's going to look like, okay? Because some combinations just can't happen. So there's no way that this can be sticking out forward and this could be setting back when I have a top view that looks like that, okay? So that's kind of how that works. And this is my orthographic drawing. So let's go down here and let's pick. My top view is one of these options. My top view is going to be C. So if you want to put C in that spot, my left view is this guy right here, no dimension change, so that is E. My front view is this guy right here, which is D. And then my right view is this one. That's the only option it can be. Well, I guess B, it could have been B, but it has to have that dimension change right there. So that is G. So that is my, it's called an orthographic drawing. You have 4 different sides of your object, top, front, left, right, that you will draw, okay? And you'll do some of those on your homework assignment. So I'll tell you what your homework assignment is here in just a minute. But let's go through example 3. This is something called a net. It's like I've taken like a box, but not a box, and I've unfolded it, okay? And what this is actually going to look like, and this is the hard part, is we have to tell what this solid is going to be. I'm actually going to draw it also, but this is going to be a like an army tent, if you think of it this way. Like these are going to fold up, and then I'm going to have like a little tent looking thing, right? He is going to be a triangular pyramid, not pyramid, prism, a triangular prism. That's kind of a bad, I don't know, you could, I don't know, back there. Maybe I should do a different view of him. Anyway, it's going to look like that, right? Like where that's set back further, okay? If I label these dimensions, this bottom is 16, this is 10, this is 10, right? Like 16, 10, 10. And then this side is going to be 20, okay? But this is a triangular prism, okay? Now, or they say then find its surface area, okay? So rather than, how do I want to do this? Rather than finding the surface area going off of the 3-dimensional figure, let's just find the area of all of the surfaces on here. So this guy is a rectangle, right? And he has 20 by 10, which means that his area will be 200. If I take 20 times 10, base times height, that means this one is also 200, okay? This guy is a 20 by 16. If I multiply those together, that's going to be 320 for this bottom rectangle. And then I have 2 of these triangles that are going on here. And the problem with those is my base is going to be 16, but my height is this thing right here, and I don't necessarily know what that is, right? Like it's not labeled. So what I'm going to do here is I need to find what that height is, question mark. I know that this is 10 and this bottom part is 16, which means that this guy is 8, right? Like half of it would be 8. So if I'm looking for this height, we could do the Pythagorean theorem to find it. I'll call that a squared plus 8 is going to be my b, and then 10 is going to be my c. So x squared plus 64 equals 100. If I subtract this 64, you might already know that this is a Pythagorean triple. If I take the square root, this is going to be 6. So the height here is 6, okay? So if I do base, that's 16 times the height, which is 6. It's kind of weird looking at it like that because it doesn't look like a base and a height. So 16 and 6. If you look at my 3-dimensional figure over here, you can see it. 16 is the base. The height is 16, but I have to take base times height and divide by 2. 16 times 6 is 96, I think, or something like that. Yeah, 96 divided by 2 is going to be 48, right? But here's the deal. Like, I know some of you guys are shouting at me like, why are you dividing by 2 when there's 2 of them? So I have to multiply that by 2, and that makes 96 again. Or I could have just forgotten about dividing by 2 to begin with, right? So those 2 together are going to be 96. So I've got 96 plus my 200 plus my other 200 plus my 320. And that gives me, I don't know, 816 inches squared for a surface area, the area of all of the surfaces together. I could have, if I wanted to, use the surface area formula for that shape. That would have worked too. But anyway, we already have the net drawn out, so we might as well just do it that way. Okay? Oh, here, they have a better picture of trying to find their height, probably there. Right, the Pythagorean theorem. Okay, all right. Next, let's do example 4. We don't have a whole lot of these. I don't really focus on example 4, but I do have one question like that. Maybe I don't. On your homework? I don't know. If we would fold all of these together, it would make that 20-sided, like, I don't know if we made it, if we said he kind of looked like the, what's that thing called at the zoo? I don't know. The Desert Dome. There it is, right? It's like the Desert Dome, but smaller, right? 20 equilateral triangles is something called an icosahedron. Okay? All right, these guys kind of look like flowers, right? But if I would put them all together, it kind of looks like that soccer ball thing. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is, I think, a dodecahedron. Because 12 is do. So dodecahedron, that's like that soccer ball looking thing. Although you guys said the soccer ball is actually pentagons and hexagons. Whatever. Anyway, those are all, that's the net of what it would look like if you would now then fold it back together. It would be that dodecahedron. All right. Last couple things. Draw nets for the 4 three-dimensional figures. This guy is a pentagonal pyramid. He comes to a tip at the top. So he has a pentagon on the bottom. If I unfold him, he looks like this. Yeah, that's kind of fancy. Now, I could have also, if I wanted to, made this net look like this. And you might think, oh, no, this is not a pentagon. That's a hexagon, by the way. Anyway, you might think this is a silly drawing, but I'm going to draw it like this anyway. So let's say I do this one, right? And then I have this one going on. And then I have this one going on. And then I have this one going on. Oh gosh, I'm getting really bad at my drawing here. Something like that. 1, 2, 3, 4, 5. Let's go 6 right here. So I could draw my net to look like this instead, where it kind of like fans around, and then this guy's going to come here as I wrap him back around, right? That guy will come here. This guy will come back over here. And then this guy will close it all the way up. I don't know if you can see that, but that's another way of drawing the net. You're like, that's not the way that this one makes the most sense. It's like fanning it open, but you could fan it open like this, right? That's another way of drawing a net, okay? So this check, draw a net for the rectangular or for the regular pentagonal prism, okay? So they want us to draw a net for this guy. The first one was drawn. I showed you a different example. They want us to draw this one fully. So I'm going to start with a pentagon. Just like this. Whatever, do your best, okay? Now you can choose what you want to do for this pentagon. I'm going to do like this. These are going to be the sides that are going to like flap open, right? Like that. And then I'm going to put one more pentagon right here for the lid that closes up to the top, right? And what I'm going to do is I'm going to say that this is 15. Whoop. Wait a second. I'm going to say this is 15 because that's the length of this side. And then I'm going to do this. Tick, 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 tick. So I show that all of those are 15s. Now this is also going to be 15, right? And then I have 12s, which are the heights of the boxes. So this is 12, and I'm going to do double tick, double tick, double tick, double tick. So I show that those are all 12s instead of 15s, okay? So you can kind of see my dimensions, all right? Now some of you guys might have drawn this a little bit differently, like, let's see. Okay, here's another way of writing it. So let's say I have my pentagon. I'll make this one smaller. Okay, did anybody do this, I wonder? Okay, here's my pentagon. And you did this. Something like that, right? And then you flap him closed and you wrap that around it. That would have worked too. Okay, so that's another way of drawing that net. And then you label all of your stuff. Make sure you label the dimensions, and then, you know, if you want to put the tick marks on there, that's helpful too. But at least put your 12 and 15 on there somewhere. But yeah, there's many different combinations of how you can unfold this box, okay? All right. Last one, draw a net to represent this three-dimensional figure that can be used to model this tent. Okay, I'm going to first start with this bottom shape. That's a 5 by 7. So let's say this is 5 and this is 7. Okay, now he's looking like that. All right, now I have like this shape here, which is a pentagon, but he's like straight here, and then this, like, he looks like the front of a house, right? I'm going to do the same thing on the back side because he's flapped open on the back. So like I've torn this back down and I've torn this front down, right? Okay, now I've got this side right here. I'm going to pull him out this way, and I've got another side going on here. Like that would be like this side and this side. And then I've got the top flap, which is another rectangle. So I'm going to do it like that. So kind of similar to the one that I just did. This dimension right here is going to be 4 because that's 4 tall. And then this right here is 5 because that slant is 5. So 4, 5, like that. Yeah. Yeah. I'm not going to label them too much more than that. So that's an example of what a net could look like. They kind of started off doing the same thing that I did, right? They need 2 more over here to make the side and the top and the side and the top. Yeah, so there's that. Okay. All right. And this one doesn't have a name for that shape. I guess he would technically be a pentagonal pyramid, but these pentagons are not what's called regular pentagons because not all the sides of those pentagons are all going to be the same because this bottom is longer, right? Like this is longer than these sides right here. So he's not a regular pentagon, but he is still a pentagonal pyramid or a prism. Okay? So example 6, that's an example of what a net looks like. All right. So what I want you to do for homework is these are the orthographic drawings, and I think maybe we drew those on dot paper the other day, but I'm not going to have you do that. I'm not going to have you do any more dot paper things. But what I want you to do is do the orthographic drawings for 4, 5, and 8. So you have 4 different drawings to do. You've got a front, a left, a right, and a top. Okay. So do each one of those. It doesn't matter which one you do first, obviously, but do each one of those for each of those 3 objects. And then on the back side, what you're going to do is do your very best to try to graph what this looks like if you fold him back together. I know it's hard, but try to see if you can figure out what 9 and 11 look like, and then make sure you identify the solid and find its surface area. So don't forget to do that part. And then the last thing is 17 and 18. So these ones, these 2 you're breaking apart, you're unfolding, and then these 2 you're folding back together. Okay, so you're drawing nets down below, and then up above you're just doing those 2. So not very many homework problems. You've got lots of time in class, hopefully, to work on those. And then tomorrow we will finish the last section of the chapter. We've already done 2-7. Tomorrow we will do 2-8, which is sig figs. So that should go really fast for Friday, especially with shortened periods tomorrow. Okay, so be prepared for that. That's coming.